Hello, it's Dr. Sherman, and I'm here to outline the Simple Pendulum Lab. The purpose of this lab is to predict and test how the period of motion is affected by the amplitude, the mass, the gravitational acceleration, and the length of a simple pendulum. We're going to also apply results of how the period changes for a different length and plot that using a linear graph to find the acceleration due to gravity. In the first activity, you're going to predict how the period of motion, or t, is going to change depending on the amplitude theta, that's the angle here, the mass that's on the end of the simple pendulum, the gravitational acceleration, or g, and the length of the simple pendulum from the pivot point to the center of mass. In activity 2, you're going to test your predictions using a simulation. So with the simulation, which I'll show you in a moment, we're going to take data for each case of how the period of the pendulum is affected when changing the amplitude, when changing the mass, or when changing the length. We're going to take that data and graph the results for each case using the graphing software Graphical Analysis, which you downloaded and installed last week. Let's take a look at the simulation you're going to use. This simulation is from PhET Interactive Simulations Project at University of Colorado Boulder. It's called the Pendulum Lab HTML5 and should be compatible over multiple devices. You can get to this simulation from your lab assignment. In the necessary equipment, there is instructions on how to open the simulation. Also, there is a direct link within the lab itself on activity 2. Go ahead and click the link. You want to open the lab version of the simulation. You'll see a screen as displayed. To make this pendulum move, you're just clicking and dragging it. I'm going to pause it, or you could stop it. You can use slow motion or normal motion. You can change the length here. You can change the mass. You can set the gravity to be Earth or some other form of gravity. For the most part, we're going to leave friction as none. You are not required to see the velocity or acceleration vectors during the motion, but it might be interesting to see those vectors displayed. Similarly, you are not required to use the energy graph available, but it might be interesting to see that information displayed. You will be required to use the period timer. That's down here, and as you can see, I need to start it, and it will measure the period of one complete oscillation. After you've collected your data, you're going to plot using the Vernier Graphical Analysis program that you downloaded and used last week. Refresher documents on using graphical analysis are also in the necessary equipment section. Go ahead and open up that link. It shows you where to go to download the program if you need to do that, and some different tutorials and help documents that you can use along the way. It also summarizes some of the common usage of graphical analysis. In activity 3, you're going to use your period versus length data to find the acceleration due to gravity, or g. Let's take a look at what you're going to do to manipulate your equation for period so that you can use that with a linear graph to find acceleration due to gravity. So we're going to linearize the equation first. The equation is given as 2 pi square root of L over g. And with the square root in there, it's not a linear equation. So we're going to square both sides. And now what we have is actually t squared versus L. And the value in front of the L can be used to find g. So in terms of a linear equation, remember a linear equation is y equals mx plus b. Our y in this case is going to be t squared Our slope is going to have g in it. Our x, or the data plot on the x-axis, the thing we're allowed to change, is our length. And the y-intercept will be 0. So we're going to plot t squared versus L and use the slope to find g. So you'll notice I've got t squared on the y-axis, length on the x-axis. I'm going to do a linear curve fit. And from that linear curve fit, I'll get some kind of slope. And from the slope, I'll use that to calculate g. The discussion questions for this lab are: how did graphing help you understand how the mass, amplitude, and length affected the period of the pendulum? And if this were not a simulation, what kind of errors do you expect from this lab in particular? If you have any questions about this lab, please contact your lab instructor. The best way to reach them is through the question forums. They will be monitoring these question forums, and by you using those question forums, they can address questions from many students at once. You could also email your instructor directly using the instructor contact information posted at the top of the As You Learn page. And your instructor has set up a Google form to set up a one-on-one meeting if that is necessary. Well, thank you, and I hope you have a successful Simple Pendulum Lab.